Hello friends, this is Dr. Chandan Mohanty and today in this video I am going to discuss on the topic nonlinear pharmacokinetics part 2. In my last video nonlinear pharmacokinetics part 1 I have already discussed in detail regarding the introduction, Michaelis-Menten equation, the differences between linear and nonlinear pharmacokinetics, what are the various causes of nonlinear pharmacokinetics, and what are the various methods to detect nonlinear pharmacokinetics. So that video link I have given in the description. Also you will get in the I button. In this video, I am going to discuss on 3 points, 3 topics, that is Michaelis-Menten plot. What is the plot of Michaelis-Menten equation? Then 3 cases depending on the values of Km and C. In this Michaelis-Menten equation, we are having Km and C. Depending on the values of this Km and C, what are the 3 cases will arise, we will discuss. Then last, estimation of Km and Vmax. In this Michaelis-Menten equation, how this Vmax and Km can be estimated, we will discuss. So this is a very important topic. This question used to come in the final exam of Bpharmaceutics 6th semester and Pharm D 4th year. So without delaying much, let's start. This is Michaelis-Menten equation. Minus dC by dt is equal to Vmax C by Km plus C, where minus dC by dt is rate of decline of drug concentration with time t, Vmax theoretical maximum rate of the process, C plasma drug concentration, and Km Michaelis-Menten constant. So this graph is Michaelis-Menten equation plot. This graph is plotted C versus dC by dt. dC by dt is elimination rate and C is plasma drug concentration. So if we will see this graph will increase, then it will go on at a constant zero order rate. At low dose, it will follow first order kinetics. At high dose, it will follow zero order kinetics. But at intermediate dose, neither low nor high, it will follow mixed order rate, mixed order kinetics. So this is Vmax theoretical maximum rate of the process, and this is half of the Vmax. So this is Michaelis-Menten plot. Depending on the values of Km and C, 3 cases will arise. Case 1 when Km is equal to C, case 2 when Km is much more than C, then case 3 when Km is much less than C. So what will happen to Michaelis-Menten equation in these 3 cases we will discuss. So before going to that, let me tell what we mean by an order of a reaction. So this formula is a general formula for an order of a reaction. Minus dC by dt is equal to Kc to the power n, where n is order of a reaction. In case of first order reaction, n will be 1. So in that case, minus dC by dt will be equal to Kc to the power 1 means minus Kc. In case of zero order reaction, n will be 0. So C to the power 0 will be 1. So when there is zero order reaction, this will become minus dC by dt is equal to minus K, because K into 1 it will be K. So in first order reaction it will be minus Kc. In case of zero order reaction it will be minus K. So let's start these 3 cases. In case of Km is equal to C, then what will happen in this Michaelis-Menten equation? This Km plus C can be written as C plus C, because Km is equal to C. So C plus C will be 2C. 2C, here 1C will be get cancelled. Then this will become minus dC by dt is equal to Vmax by 2. So here minus dC by dt is equal to half of the Vmax. That means when Km is equal to C, minus dC by dt will be half of the theoretical maximum rate of the process. Then let's come to case 2 when Km is much more than C. So what will happen when Km is much more than C? then we can write Km plus C is equal to Km, because C is negligible as compared to Km. Km is much more than C. So in place of Km plus C, we can write Km. So here in this Michaelis-Menten equation, in this Km plus C, we can write Km. So it will be minus dC by dt is equal to Vmax C by Km. So that Vmax by Km is Ke, means elimination rate constant. So in case of when the Km is much more than C, this equation will become minus dC by dt is equal to Kec. Why Ke? Because now I have told that Vmax by Km is Ke. So that it will be Ke into C. So when Km is much more than C, in case 2, minus dC by dt will be equal to Kec. So this equation is looking like this, minus Kc, Kec. So when Km is much more than C, it will follow first order kinetics. Then we'll come to case 3, when Km is much less than C. When the Km is much less than C, then this Km plus C will be equal to C, because here Km is very much negligible as compared to C. So this Km can be omitted. It is very much negligible. So Km plus C will be C. So if you'll see in Michaelis-Menten equation, in this place Km plus C, we can write C, because Km plus C is equal to C. So this C will be get cancelled. It will become minus dC by dt is equal to Vmax, because this C will be get cancelled. So this is looking like zero order rate, because here minus dC by dt is equal to K minus K. So here minus dC by dt is equal to Vmax. So it will follow zero order kinetics. So in case 1, when Km is equal to C, it will become half of the Vmax. In case 2, when Km is much more than C, it will follow first order kinetics. And case 3, when Km is much less than C, it will follow zero order kinetics. Now the most important estimation of Km and Vmax. How the Km and Vmax of Michaelis-Menten equation will be estimated. So this is our Michaelis-Menten equation, minus dC by dt is equal to Vmax C by Km plus C, equation 1. If we will integrate this and we will convert into log base 10, this will become log C is equal to log C naught plus C naught minus C divided by 2.303 km minus Vmax T by 2.303 km. Let's it be equation 2, where C0 is the drug concentration at time 0. Then if we will plot a graph between time versus log C, we will get a curve like this. And if we will back extrapolate, here this point will be log C naught back, and this will be log C naught. And this equation, this straight line equation will be log C is equal to log C naught back minus Vmax T by 2.303 km. So this will be a equation of a straight line, means y is equal to mx plus c, where y is log c, here y, x is t, x-axis, m, slope will be Vmax by 2.303 km. See here the terminal linear portion of the curve with slope minus Vmax by 2.303 km. So this equation will be same like y is equal to mx plus c, where the C0, C will be log C naught back. This point is log C naught back. And this will be equation 3. At low plasma drug concentration, equation 2 and equation 3 will be equal. Means this equation and this equation will be equal when there is low plasma drug concentration. So what will happen? This is log C is equal to this. This is log C is equal to this. So this part will be equal to this part. Same thing it is written here. Log C0 plus C0 minus C by 2.303 km minus Vmax T by 2.303 km. This part is equal to this part log C0 back minus Vmax T by 2.303 km. So this will be get cancel. Vmax T by 2.33 km and Vmax T by 2.303 km will be get cancelled. So it will become log C0 plus C0 minus C by 2.303 is equal to log C0 back. And if you will take this log C0 to this side, it will become C0 minus C by 2.303 km is equal to log C0 back minus log C0. As we know, log C0 back minus log C0 can be written as log C0 back by C0 because we know log M minus log N is equal to log M by N. So this will be C0 minus C by 2.303 km is equal to log C0 by C0. From this equation we can find Km because here every data we are having. So if we'll put the values, we'll get Km value. And if we'll put this Km value in slope, here we are having Km. So we will get Vmax. So from this equation, we will get Km, and that value of Km, if we'll put in this slope, we will get Vmax. Thus, Km and Vmax will be estimated. So here these equations you need to practice. One more method for estimation of Km and Vmax is double reciprocal method or Lineweaver-Burke plot method. So what will happen in this method? We need to take the double reciprocal of our Michaelis-Menten equation. We know our Michaelis-Menten equation is minus dC by dt is equal to Vmax C by Km plus C. So if you will take the double reciprocal, means we have to reverse this equation, then it will become minus 1 by dC by dt is equal to 1 by Vmax C by Km plus C. So 1 by this and 1 by this. So it will become minus 1 by dC by dt is equal to, this will be reverse, this will become numerator and this will become denominator. So Km by Vmax C plus C by Vmax C. Km by Vmax C plus C by Vmax C. So this C to C will be get cancelled. So it will become minus 1 by dC by dt is equal to Km by Vmax C plus 1 by Vmax. So this equation is also a equation of a straight line. If you will see minutely, this will be y is equal to mx plus c. So this will be y, then x will be 1 by c, Km by Vmax will be slope and 1 by Vmax will be cy intercept. So if we will plot a double reciprocal plot or Lineweaver-Burke plot between 1 by dC by dt, 1 by dC by dt and 1 by Cm, this 1 by C, we will get a straight line whose slope is Km by Vmax, and its y intercept will be 1 by Vmax. So from this y intercept we will get Vmax, and this value if we substitute in slope we will get Km. So from this y intercept we will get Vmax, and from this slope we will get Km. Thus by using Lineweaver-Burke plot method or double reciprocal method we can also get Km and Vmax. Thank you for watching this video. I hope you liked it. It requires much effort to prepare this kind of PPT and videos because here so many equations are there, so many graphs are there. So please press the like button if you really liked it. Very soon I will come up with a new more video. Till then, take care, stay healthy, stay safe. Bye.